Sure. Let me visit my own website just to make sure that this is working. And then I will, assuming it is working, go ahead and get started. Yep, I can see it showing up there. Great. So thank you all for joining. I'm just going to check one other thing, make sure that it's showing up in a couple other places. I am going to be building some maps that show the impact of wildfires in Oregon. If you're on the West Coast, of course, you're going to be familiar with the wildfires that have happened. So I am building, actually I'm just checking to make sure. Okay, perfect. It's showing up on Twitter as well. Awesome. Yeah, these maps that I'm building, you probably know because I sent out an email to my list and it posted on Twitter, are for a client that I do consulting work for. It's called the Ford Family Foundation. And they have partnered with a couple other foundations here in Oregon to develop a fund to help folks recover from the wildfires that have taken place. So what I'm doing today is really just building, it's like my first time looking at this. I've kind of done a bit of prep, but not a ton, because I want to actually kind of work live and do it with you today. So I'm basically gonna take some data that exists out there, and then I'm gonna work on building some maps. So I actually I'm just gonna post one thing. This is all gonna be posted on in a GitHub repo, and I'll post that. It should show up. I'm on YouTube, Twitter, and Twitch right now. It should show up in all those places. Feel free to take a look after I finish today. You can get all the code, see how I did everything. I'm going to make it completely reproducible so that if you were to download the code and run it yourself, it would work for you. At least that's my goal. If I do a good job, that's what I'll do. So I'm just typing this in so you can find the code at. So you should be able to see all of that. And if you have questions or comments as I go along, I'd love to get your feedback. Any of the places that I am streaming to, you can post comments. If you see me looking over at my other screen, it's because I can see all of the comments. So I see a couple folks who are watching. Thank you. Hello. And yeah, please, provide me feedback. I do not claim to be. I'm going to be doing a bunch of geospatial work today. I am. I'm pretty good with geospatial stuff, but I'm definitely not a geospatial expert. So I know there may be folks who are watching who have more expertise in this area than me. So feel free to chime in. So what you're seeing now, I started with a README in the package that I created, and this is, actually I'll just pull this over here. This is the GitHub repo that I've created. I actually just updated it. So just provides a bit of information about what I'm doing. As I was kind of thinking about this over the last a little while, I looked for other kind of visualizations that folks have made of the wildfires. So I have some links to other ones that I think are really good. And then I'm posting a link here to some of the data that I'm going to use. So actually I'll just open these three. I think it was the LA Times is the one that actually pointed me to the data. So they did a really nice map looking at fires across, well, it says California, but it also includes other states. So just let this load. Sorry, this is kind of taxing on my system. Okay, so they are, might have to close this, kind of a lot for my system. Anyway, so they're showing all the maps, a bunch of different layers. They're showing where there are active fires, fire perimeter, number of hotspots. But the nice thing is I looked at this section about this data, and they provide links to where they got all their data. And so I looked at, what was it? The perimeters provided by this GeoMac, which is linked up here. So that actually ended up pointing me to this, the Wildland Fire Open Data from the National Interagency Fire Center. I'll open that. So I also, posted a couple links. This is from Bloomberg. They did an amazing map here looking at the impact of these fires. My map is not going to be this detailed. I love how they did the shading to show elevation. Or actually, I don't know if that's elevation or trees or I don't know exactly what it is. But in any case, it's beautiful. I don't need that level of detail. I probably won't do anything that complex. The other thing is from the Washington Post. It actually kind of is similar to the Bloomberg piece with a really nice map showing fires. So I'm going to switch over to R. And the first thing that I need to do is just download the data. So let me flip back here to the Interagency Fire Data Center. So I just went to the website here, and I did this morning just because I wanted to make sure that I would have data, but I haven't done anything beyond this. So I went to, looks like they have a couple different pieces of data here. I went to current wildfire perimeters, because first thing I just want to show kind of where the wildfires are. So here's wildfire perimeters. And when I looked at it, it's kind of strange. They have, I'm just going to close some of these windows for simplicity. They have wildfire perimeters and then archived wildfire perimeters. So I think the first one, I don't quite get why they do this, but the first one shows active wildfires right now. And the second one, this archived wildfire perimeters, shows wildfires for 2020. And so it says they're all controlled, contained, out, orphaned, or automated perimeters that are greater than 7 days old. So again, I'm not really sure why they divided it up this way, but that's what they did. This is the one that shows the current wildfire perimeters. So you can see in a second it'll load a map here. Hold on one second as I wait for this to load. All right, so if I zoom in here, you can see the perimeters of the data. So I can see these fires that are burning right now. So what I did, a couple ways to access this. So you could just download it. So I can download it in all these various formats. I'm not going to go into super great depth about the different formats because actually what I ended up doing, I think this is right. No, sorry. I went to the APIs section. So they have an API, which is just a way for you to automatically connect to the data as opposed to having to manually go and grab the data or hit that download button. What you do is you can just download a copy, or you can just get a URL that actually gives you access to the data, gives you a copy of it. So It provides it in a couple different ways. To be honest, I had never actually worked with either. I didn't know what exactly was going to work, but what I decided to do was try this GeoJSON because I've seen that format before. And so what I did first thing, so I loaded my packages. So I am using, actually I don't think I'm using the SF package. I'm using tidyverse because I use it for everything. I'm using the janitor package, which actually I may or may not use. I use that primarily for the clean names function, just to give me nice variable names to work with. And then I'm using the SF package, which is all, basically I'm going to use for getting and working with geospatial data. So I'm going to load these packages. Then what I did, this URL here is this exactly here. So like even I'll just like copy it in, and so you can see that's the same thing. I'm just using the download.file function, and that just allows me to actually download it so that I have a copy of this data. I could also read it indirectly, but I did it because I don't want to, if I have to like restart my session or something, I don't want to have to spend the time to download it. So I'll go ahead and run that. And you can see it says it's just downloading it. It's going to put it in here, so it'll take just a second. Okay, cool. So it downloaded, and you can see I have it here now. What I'm going to do just to be safe is I'm going to comment these two lines out so I don't accidentally run them again, because I don't need to re-download it. So now what I'm going to do is I'm going to read this data in. And so I'm using the stRead function from the SF package. So again, I'm not going to go into super great depth on any particular thing, but the thing that this does is it reads in kind of geospatial data in some kind of external format. And like I said before, I'd never actually used GeoJSON data. So I was like, I don't know, let me try and see if I can just use the stRead function. I use that primarily for shape files that are in like SHP format. So I ran that, and it'll take just a second. Geospatial data tends to be really big and just a bit slow to work with. Although this is particularly slow. So basically what I'm trying to do here, which will hopefully work in a second. Something might be wrong. Oh no, it is working. Is I'm reading it into an object called wildfires current. Oops, that's not what I want. Okay, why is this going so slow? I did this morning to check and make sure it worked, and it did not go this slow. I may have to stop. I'm just going to stop, and I'm just going to restart my session. So I'm restarting my session, but you can see I can leave these two lines commented out. I don't need to re-download it. So let me just run down to there, and let's see if it goes any faster. Maybe it will just take a while because it's 58 megabytes. It's weird though, it ran faster this morning. Maybe it's just because I'm streaming, which again takes a bunch of resources on my computer. While I'm waiting, I'm just curious, like if you're watching, who you are, what you do with R, and where you're located. Feel free to put that in the chat. Any of the places that you're watching. I see Victor is watching. Thanks for joining, Victor. And Francis from the UK. Hope your dinner cooking is going well. Cool. Oh, actually, it looks like it worked. So I have wildfires current here. Oh, cool. Someone's watching from Italy. Excellent. Um, so if you have seen me code in the past, you know I really like to use the viewer. I'm a visual person. I like just opening it up and it, pop up here and I can look at it. Victor's from DFW, which I think is Dallas Fort Worth. Excellent. Thanks, Victor. I'm actually not going to pop things up generally when they're shapefiles or when they're SF. When they're geospatial data, basically because it's huge and it just takes a while to open up. So what I want to do is I just want to kind of look at this data. The thing with the way that files in the SF format work is they have a bunch of variables, and then at the end, like if I actually just type that, you can see the variables, so object ID, incident name, feature category, all this stuff. And then the last column is a really kind of special column that is geometry. Oh, hi, Aiden. So Aiden is from Ford Family Foundation, who I'm actually building this for. Thanks for joining. Anyway, so this last column, this geometry column, is a special column that provides the geospatial data that we'll actually use for plotting. So one thing I'm going to do, just because I'm particular and like to have things in a nice format, is I'm just going to use the clean names function that will just make all of my variable names go to lowercase, and it will put underscores between words. It's totally not necessary unless you're me and you just want to have everything exactly right. So you can see now it just changed things to like incident underscore name. Okay, what I'm going to do now, just so I can actually like see it, is I'm going to do wildfires. Actually, sorry, I did that too fast. Wildfires current, and then I'm using the pipe because I'm tidyverse guy. I'm going to use st drop geometry. So what that's going to do is it's just going to get rid of that geometry column. And then I'm going to use the view function just so I can pop up the results, just so I can take a look at it. And again, I'm just doing that, dropping the geometry, just because like it would take forever to load if I don't do that. So looking at my data, let's see, object ID. So it looks like they give an ID to each fire. There are names, feature category. So it looks like these are all, oops, wildfire. Oh yeah, it looks like they're all wildfire daily fire perimeter. Map method. Oh, that's interesting. It looks like there are kind of different ways that they collect data on this. Huh, interesting. Comments. Then it has the number of acres, which will actually be really helpful for me. Label, I'm not quite sure what that is. I could go back to the place I downloaded it and see what kind of data they, or what metadata they post, but I'm not going to worry about that for now. Feature access, looks like this is all kind of like internal stuff. So create date is the date, I assume, that they created this record. I don't know what date current is. I might actually have to go back and look at this. Then it looks like polygon date time. You know, I think I do need to see what I can read about this. Let's see if I can view the metadata. Because what I'm guessing is this is the data was created, the current date. I assume that's like the most recent. I don't know what that is because polygon date time comes after that. So I'm a bit confused about that. Let me see if this tells me anything in terms of metadata. This is cool. This is unrelated to what I was just saying, but it's updated every 5 minutes. So if I were to run this, in 5 minutes, it would give me new information. I don't actually see what this is. I'll probably have to look into that later. I'll deal with it as it becomes necessary. Because I want to focus on the actual coding part, again, I'll deal with it later. So it gives me shape length and then shape area. I'll have to look into how area is defined, although actually, to be honest, I'll probably just use the acres one. Okay, so I think what I did then in addition to that is I downloaded the archived version. So this is just this other one that has like all the fires from 2020. This is actually going to be even bigger. And then I set up the code to do the same thing, basically just to read that in. So I think what I'm going to actually do, just starting out, is, so I made a separate file. Actually, I should probably put that, hold on one second. Let me put this in the right place. I'm just going to close my import data file for now. I'm just putting it in the data raw folder. I like to have a kind of data raw folder which just literally has raw data, and then any processed data that I have I could save as something else. So now, for example, actually I think this is what I'll do. So what I'm going to do is first I'm just going to create a data folder. This is actually kind of a common structure for packages. This isn't actually set up as a package, but I'll just use it in a way, like kind of the same way. So I'm just going to save this data. So I'll do wildfires current. I'm going to write this to an RDS file, which is just a native format that R uses for saving data. So wildfires current. So if I go back in here, you can see now I have this wildfires current. It's only 22 megabytes, so it hopefully will load a little bit faster. So what I'm going to do now is I'm just going to make a new R script file. I think this is going to, I don't know if this is going to end up being an R Markdown document or an R script file. Actually, I'll just call this data viz. So I'm just going to go ahead and start with creating this. I like to kind of do all my data processing in one file and then just my data visualization in another file. Obviously, I didn't do a ton of data processing. All I did was just download it and then write it to an RDS file, but I may want to do some other things. So actually, you know what? I take that back. I might want to do this. So what I think I want to do is actually get Oregon and Siskiyou shapefiles. So I've set up till now that I'm doing visualizations on data or on wildfires in Oregon. That's actually not entirely correct. I'm also looking at Siskiyou County, which is one of the northernmost counties in California where the Ford Family Foundation also works. So I'm going to bring in that data because I'm going to actually use that to, right now this wildfires current is like every wildfire in the US, I think. I only need a subset of that. So to get a subset of that, I need to figure out which are the files that are in either Oregon or Siskiyou. And unfortunately, there was no, oh wait, I don't think I want to do that. That's going to take forever. There was no way, like there was no variable that was just like state. Obviously, that wouldn't quite make sense because wildfires can go across states. In any case, what I want to do is I want to import, I want to get some data that is Oregon and Siskiyou, so I can use that to whittle down the wildfires that I need. So I am going to use the Tigris package. And actually, I'm going to cheat a little bit. I have created a package for, hold on, just, for the Ford Family Foundation, where I do things like bring in data for, because I do a lot of mapping. So I've basically already written the code for this. So what I'm going to do is I'm using the Tigris package, which allows you to bring in shape files. So I've written it this way, like actually showing the package that it comes from, because it was written as part of a package. I can just delete this to make it simpler. So what I'm doing, this counties reads in a county shapefile. So that will read in, actually that's not what I want. That's every single county in the state of, or in the US. So what I'm going to do then is I'm just going to use the clean names function, and then I'm going to filter so that the state equals, state FP equals 41, which is, I can't remember if that's, I think that's Oregon. And no, sorry, that's California. 6 is Oregon. So I'm basically saying only keep Oregon or California. And then for state 41, only keep Siskiyou. So let me go ahead and run that. And you can see now I have a file that has the states, it's basically a bunch of kind of ID variables, the name of the county, I think it's like the square meters, that's land. It doesn't really matter for my purposes. I think it's like amount of land, amount of water, something like that. I don't remember the exact details. I could look it up. But what I have is a shapefile. So let me just actually begin by showing like how easy it is to plot a shapefile to make just like a very simple map. So if I do ggplot, and I do, so my data will be Oregon, Siskiyou. I literally now, at this point, just use the geom_sf function. What did I do wrong? Do I not need data equals? Yeah. Popped up for a second and then it went away. Why is it doing that? There we go. So you can see I've now made a map. Obviously it has the kind of background, which I don't need. So if I just use like theme void, which just like strips all the background, you'll see it'll show up as a map with a blank background, which again, like plotting geospatial data just takes a little while. I know the folks at RStudio are working on kind of improving the speed here. There we go. All right, so I'm probably not going to need counties. Actually, now that I think about it, well, it's that's not true. I need one county in California and Oregon. So, how do I? What I'm thinking I want to do is just create like a single polygon that does the boundaries around all of this. So I don't actually know. I actually have to look up the with SF package. Try to remember how I did this. You know, I just did this for another project. I am going to see if I can bring this up. So I think I could do, well, that would be bind rows. Let me try. No, that's not exactly what I want. Okay, well, you know what? Hold on, how do I... might be a join. Let me try this. So Oregon, no, it's not join because that would be joining multiple. If anyone knows, feel free to chime in and let me know, because I don't do enough geospatial work that I remember this kind of thing off the top of my head. Although maybe what I'll do is this. Maybe I'll do Oregon is, I think there's a state function. What I'm going to try and do is just get the data for, hold on. I want to try and get the data just for Oregon. And then just get the county data for, oh, okay, perfect. ST Union. People are actually suggesting, Francis is suggesting something, ST Union. Let me try this. So, yes, I think that worked, actually. Thank you, Francis. So what this does, let me plot this. So, and Francis, tell me if I'm wrong, but this is basically going to combine it all into a single polygon, and then I'm going to go ahead and try and plot it again, and let's see what happens. Ah, perfect. So you can see now it's just made like a single polygon. So actually, you know what I'm going to do? I am just going to add this here, because I don't actually need those county lines. I don't know, maybe I will later, but I don't think I actually need them. So now my Oregon Siskiyou data frame is just that single shapefile. Okay, perfect. Actually, you also suggested ST combine. I'm curious. I don't actually know. Let's see. Let's just try it and see what happens. Yeah, that didn't work. So definitely ST union is what we want. Okay. Now, what I want to do is I want to just keep the shapefiles from the wildfires current that are within the boundaries of Oregon and Siskiyou. So this is, again, something I just did. So I'm going to actually just look back at my code. Was it, I think it was ST or no, ST filter? Yeah. Okay. So let me kind of plot this in here. So there's a function called ST filter, which enables you to filter all the rows. So you can see we have like 1,300 observations. So I want to filter to only include the rows that are within that object. And then what you have to do with ST filter, actually, so PDX boundary was for something else I was doing. So I'm saying let's start with a wildfires current, then let's filter to only include ones that are within the Oregon Siskiyou, and we have to set a join method. There are various, what did I do? ST intersects. There are various ways to look at whether or not there is an overlap between them, and Francis, if you want to actually chime in, because here I'm not actually. I have to kind of look through the help files here, because what I want is any wildfire. Because I'm thinking, like, what if there's a wildfire that's like partly in Oregon but partly in Washington? I probably want to include that. Let me try with ST intersects and see that. Okay, so I am actually getting an error here. First of all, that's telling me STCRS equals STCRSX equals STCRSY is not true. So in other words, what's happening here is that this is the, gosh, well, I don't even know what CRS stands for, the coordinate system or the projection. I can't remember what it is. I have to look back. I always look at geocomputation with R, which is a great book online for free. Let me just add CRS to my Googling. Basically, we have to, hold on, coordinate reference system. Again, I am not a geospatial expert, but from my understanding is basically you have to, to display data, geospatial data, which is three-dimensional because the Earth is round, but we're just displaying it in two-dimensional space. We have to choose a projection, essentially. And so this coordinate reference system basically determines like how it kind of shows up. So if you, yeah, so what I need to do here is, and actually, you know what, I am going to open up, I shouldn't have even closed it, my file again where I was working last time. See if this works. Yeah, so what I'm doing is I'm setting the, yes, that worked. Okay. I'm setting the coordinate reference system. So I'm using the ST transform, whoops, function. I didn't put the argument name, but, and I'm setting the CRS. And the thing is, it couldn't work before because they were not identical. So I need to set them so that they are identical. So what I'm actually going to do, I should put this up here. So I should basically, when I read it in, I want to set the CRS, and I'll do that for both of them. Of course, that'll take just a second. And this is actually something I literally just learned how to do. I had known that it was possible, but I had never actually had any reason to do it. There we go. I actually literally just learned this like last week because I needed to do it. And it actually is relatively straightforward with R. Okay, so now wildfires current, I can filter it so that it only has those that are within that. And actually, I'm just going to add that ST drop geometry and then view so I can just kind of see what pops up. Great. Now it looks like we only have like 61. What I'm going to do now, just to kind of like see these. Okay, so I'm going to actually, hold on. I'm going to actually take this up here so that I'm going to, instead of just displaying my results, I'm going to assign the results of that filter. I'm going to basically make wildfires current. You see it how it's like 1300 now. In a second, when this finishes running, it'll be down to that 60 or whatever the number is. this take just a second. All right, cool. Now you can see it has 61 observations. And that'll actually make it, for example, if I save this, that'll actually make it a lot smaller. So like if I look at this wildfire relief, bring this over here, you can see that's now 3.4 megabytes. So that'll actually be really fast to load when I do it as part of my data viz when I'm actually really working on that. Okay. But let me go ahead and just like plot this to see. So first thing, I'm just going to change this. So I'll put the geom SF here. I'll put the data equals Oregon Siskiyou there. You'll see this isn't going to actually change anything. It should show up. It should be identical. If this is just taking a while. There we go. Okay, so now I'm just going to add a line. So geom SF data equals, and let me add this wildfires current. And I'm just going to also change the color. So I'll just do like color equals red just so it is obvious. Let's see what happens. So here you can see it is a bit slow. I could also use like the tmap package. There are a bunch of mapping packages. I just use ggplot because that's what I use for everything. Oh boy, this is actually taking a while. Is this going to work? Does that not work? I'm curious if folks have questions, please feel free just to put them in. I know, I'm trying to go decently slow to make it semi-obvious what I'm doing, but, I know there are people who are going to potentially have questions, so, definitely let me know. You know what I'm going to actually do? Let's see if I can stop this. Well, what I'm going to try and do is I'm going to actually use an interactive mapping package. Cause I'm going to use it because it just is faster. Just looking for where I put. Gosh, this is really struggling now. Hold on. Let me just clean this up while I'm waiting. And actually, I will, I'm just going to write some code right now so I can just save things. So that'll just make it a little faster. I'm going to comment this out. This is kind of the archived stuff. Seems like this may actually have quit or just really stalled altogether. So let me, I did a force quit. All right, so this is gonna, let's see. So I actually copied everything before I quit. So let me comment that out because that's what's taking a while. And I'm just gonna select all, which will run everything. It'll import that Oregon Siskiyou data. It'll save it to an RDS file. It'll do the same with the wildfires current. And then I'm going to save that to an RDS file because then I'll be able to just use those. So this is still just going to take a second as it opens that GeoJSON, which is why I want to save it to RDS in the future, so I can just open that RDS, which will be smaller. All right. Oops. This is the magic of coding right here, right? Just waiting for things to load. All right, cool. Okay, so I'll just work as if I'm working in my DataViz file now. So because I have saved my files as RDS files in my data raw folder, I can actually just restart my session and I can just load them in a much simpler way. So like I could do read RDS data Oregon Siskiyou.rds. So you can see I can read that now, and that gives me access to that object. So I'll do wildfires current read RDS data / wildfires current.rds. You can see it's like much faster to load. So let me actually just put this up here in a separate section, import data. All right, so now let me just try making an interactive map just because I think it'll go faster. So I'm going to use the map deck package, which I'm actually looking over here because I have some code on my second screen. So I'll do data equals Oregon Siskiyou. Let me just try this. Yeah, for some reason, actually, this Oregon Siskiyou, there we go. It's not showing up as an SF object, which is kind of weird. I don't know why when I did that ST union, it seemed like it made it show up not as a an SF object. Not really sure why. So what I'm going to do actually is I'm just going to rerun this again, but I added in this line here. So now it shows up as an SF object. And I just resaved it. So you can see I saved it at 11:51, which is now. So I'll close that. I'll go here. I do this all the time. I just restart my session so I know. That's weird. Why is that? Okay, there. Everything went away now. So now I can re-import this. this is how I make sure that my code is reproducible. Like if I can restart my session and have it run again for me, then I know it'll most likely work for others. Great, so I have my stuff here. So I'll go ahead and do map deck. And you can see it has shown me here, it's shown the state. Okay, so I definitely am going to need to make this lighter. So I'm just copying some code that I use from something else. So I'm making it the fill color lighter. Show up here in a second. That's actually a bit too light. Actually, let me just. You know what? I don't even actually. That's fine. I'll just leave it for now. I don't really even actually need to see that because it's showing the background map. I also know I can see like where that is. So you can see Oregon and Siskiyou have that kind of light shading. I misspelled wildfires, so now I'm just going to add data equals wildfires current, and let me go ahead and plot those and see how they show up. Okay. Perfect. So I am actually beginning to see where the wildfires are. Interesting. It looks like there's one that's showing up here. Actually, looks like it's outside of Siskiyou counties, which is weird. Hold on one second. So I'm thinking. So what I'm doing now is I'm just changing the color to a light blue. It's actually the light blue that I use for the rest of us material. And I'm going to have it show up there. And I've set this 50 at the end, which is the opacity, because I'm trying to also show, okay, I need to actually, I said before that I didn't need to see the boundaries of Oregon Siskiyou, but I think I actually do want to see them. I'll just do 99 so that I can get a sense of where, like make sure that these fires are actually in where I expect them to be. Actually just bringing this up because I want to be able to see the chat in case folks post anything there. So let's see. Okay, I don't know why. Maybe I need to make the stroke with, I forget, I think that's in meters or something. I'm going to make it really big so I can hopefully see where the boundaries are. Okay, why is it not showing that? And actually the blue is not showing up well because it just looks like a lake. So I'm going to change that to an orange, which I'll show up next time I run this. Do I need to add this like below here? Let me try that. So I'm changing the order, which should have it show up on top of that. Let's see if this works. There we go, except now we can't see the fires. Let me change the opacity here. Okay, so I definitely don't need it to be that big. So weird, my fires are not showing up here. Let me see if I can look at something I did before. So I've got my fill color. Stroke color. Try running this one more time. And actually, looking at my other code, it definitely should be, I should put this one first. So I'm literally just like copying code from something else that I did recently to see if, to be honest, I'm not exactly sure why it's not showing. Oh, there it's showing up, but I don't know if we're going to see the layer below it. Why are we not seeing that? I don't know why it's not showing up. But in any case, I think we have a pretty good sense that these are the fires we want, minus this one in near Hoopa. Let me just Google Siskiyou County to be able to see the boundaries of that and see if that looks like it's within there. So I'll do Siskiyou County. Google Maps does a nice job. If you put in a county name, it'll show you the boundaries of the county. And just to give folks a heads up, I'm going to work on this for a little bit more today. Then I'm going to actually have to call it a day, and I will probably come back on Monday. I'll tweet and email folks who signed up for notifications about when I'm going to do it next. Okay, so there's Siskiyou County. Maybe that is Hoopa. Oh, there, I think that's the fire. Okay, so Hoopa is in Humboldt County, but I'm guessing that fire goes across the county line. Okay, so it does look like that. I'm guessing that that worked. Let me go up here and just look. Cool. So let me just copy one thing over here. It'll take a second, but make a section. Just to like show you the static map. Hopefully this will work. If not, I'll just have to quit it again. But hopefully you've gotten a sense from watching me of like it's not actually that many steps to make data visualizations using geospatial data. I mean, if you look at the actual code that I use, I'll get rid of that. You know, it's really just like that many lines, so 35 lines to get the data, shape files of Oregon and Siskiyou. And then, you know, if I can get this to work, it's what, 1, 2, 3, 4, 5 lines to make a static data visualization, and you know, what's that, 7, 8 lines to make an interactive. So yeah, ours ends up being really powerful for interactive and static geospatial data visualizations. Let me give this another minute or so, and let me actually, before I also stop things, just ask if anyone has questions, feedback. Love to hear your thoughts. And I don't actually know if this, I've never had it take quite this long. I'm surprised it's taking this long for the static visualization because, oh, maybe it'll go now. It's only 61 observations. I don't know why it would take that long. It says it stopped running, but I haven't actually seen a visualization. Anyway, I don't know if this is going to work now, so I'm not going to sit here and waste everybody's time. But I'll stop for now. Say thanks everyone for joining me. Like I said, I'll probably be back on Monday. I'll post something to alert folks, and yeah, I'll work on this more. I think this is a project that I'm hopefully just going to work on kind of publicly as much as possible. So I hope folks, if you're interested, if this was helpful to you today, I hope you might consider joining me next time.